Some of the examples: copper, I told you 1 and 2, gold 1 and 3, iron 2 and 3, tin, stannum 2 and 4, 2 and 4. There are many examples. Let us remember: cobalt 2 and 3, and so on and so forth. Whereas alkali metals, they form only 1. Alkaline earth metals +2 only electronic configuration. Yes. Now, why do d block elements form variable valency? Why iron forms a variable valency? Write the electronic configuration 2 8. We should remember both the structures, shell structure as our orbital structure. Orbital structure, it is going to be 3d6 4s2. As per the Aufbau principle, 4s2 3d6, 4s2 3d6. The electronic configuration of iron is 3d6 4s2. If iron were to form Fe2 plus, it should lose 2 electrons here. What should be the configuration? 3d6 4s0, 3d6 4s, and because it has lost 2 electrons here, it has got a 2 positive charge. Why should this possess 2 positive charge when it loses 2 electrons? Very simple question, NCERT question. Why should it become electropositive? There are 2 extra protons, 26 protons and 26 electrons, 26 protons and 24 electrons only, isn't it? Because the 2 extra proton, it has got a 2 positive charge. Whereas this can also lose 1 more electron here to form Fe3 plus. What should be the electronic configuration? 3d5, again 4s0. Okay. Why should it not form, sir? Why have we not written loss of 1 electron here, Fe plus? Okay, theoretically we shall say it should be 3d6 always electrons have to be lost from the last energy level. It should go only from here. 4s2 should come in. I can ask you, it's a theoretical, never exists. Iron never forms a FeCl. Is there any compound called FeCl? No. There are only 2 compounds, FeCl2 and FeCl3, ferrous and ferric. Okay, this is only a theoretical situation. Theoretical situation. Now, hypothetical situation. It's an hypothetical. I just imagine, that's all. Now, we have to explain why it does not produce here and why it straight away loses 2 electrons. We will come back here. Right. Now, one IIT question. One IIT question. Raise your hands. Which of the following, write it. Which of the following is a correct statement? Which of the following is a correct statement? A. The number of unpaired electrons in Fe and Fe2 plus is the same. The number of unpaired electrons in Fe and Fe2 plus is the same. B. The number of unpaired electrons is same in Fe2 plus and Fe3 plus. Write fast. Number of unpaired electrons in Fe2 plus and Fe3 plus. C. Number of unpaired electrons in Fe and Fe3 plus is the same. The number of unpaired electrons Fe and Fe3 plus is the same. D. The number of unpaired electrons is same in Fe, Fe2 plus and Fe3 plus. How many of you know the answer? Raise your hand. Others? Okay, take your own time. Take your own time. Number of unpaired electrons. The number of unpaired electrons. You know how to find out, isn't it? S1 has got 1 unpaired electron, P5 has got 1 unpaired electron, P4 has got 2 unpaired electron, P3 has got 3 unpaired electron. Again P2, P1. What is the answer? What is the answer? How many of you are going to suggest answer is A? I will ask one by one. Answer is A, only 3, 4, 5 of you. Answer B, answer B, answer C. How many of you say answer C? Answer D. How many of you have not raised your hand? Please raise your hand now. Those who have not raised your hand, please raise your both your hands. It's a feedback for me. Yes. Shall we see the answer? How many unpaired electrons in S2 is completely filled? D6, 5 orbitals, 1, 2, 3, 4, 5. 6 comes and pairs up here. So how many unpaired electrons? 4 unpaired electrons, isn't it? Do you understand? 3. Let me go start from 3D1. How many unpaired electrons? 1 unpaired electron. 3D2, as per the Hund's rule, each orbital should contain 1 unpaired electron. When all the orbitals have got single electron, then pairing takes place. D1 has got 1 unpaired electron. D2, D3, D4, D5, D6, D7, D8, D9, D10. So D6, how many unpaired electrons? 4 unpaired electrons. What is the configuration? 4 unpaired electron. What is the configuration? 5 unpaired electron. What does the statement A tell you? Fe and Fe2 plus have got the same electronic configuration. The answer is A, and B, C and D are incorrect. Do you agree with me? Are you convinced of the answer now? Now you know how to answer such questions? Good. Is there anyone who want me to repeat? Yes. The number of unpaired electrons, I told you D1 has got 1, D2 2, it goes 1, 2, 3, 4, 5. Then 6th electron comes and pairs. D1, 1 unpaired electron, D2, 2 unpaired electron, D3, 3 unpaired electron, D4 here and D5 here. D6 should come and pair with any of them. Any of them. What do you call that orbital? The orbitals with the same energy level, without referring to earlier page. Degenerate orbitals. Because a degenerate orbital can, let's say it pairs up here. Now unpaired, how many unpaired electrons? 4 unpaired electrons. D7, 3 unpaired. D8, D9, D10, 0 unpaired electron. Therefore, I told you this has got only these two. What is the next one I told you? Fe and Fe3 plus. No, it isn't correct. 4 unpaired electron, 4 unpaired electron and 5 unpaired electron. The last statement, obviously it is going to be incorrect. Yes?
So for Fe2 plus, sir, the configuration is 3d6 for a 0.
No.
But then going with the previous thing you gave for copper, since half filled is...
No, wait. Copper is an exceptional. We'll take up the copper later.
Why won't this become 3d5 and 4s1? Because half filled is 1.
Where is 3d5? No. It's only possible for the element, not for the ions. The element only you have to make use of those rules, exceptions there. Modified Aufbau rule. You cannot modify your Aufbau rule for the ions here. Please note, make a note of it. It's a good question. The modified Aufbau rule should be there only for the elements, not for the ions. The number of unpaired electrons in Cu plus A1, B2, C3, D4. Who is going to give me the answer? Oh, you are referring to the electronic configuration of copper. Copper is 29. As per the Aufbau principle, it is going to be 4s2 3d9 or 3d9 4s2. Therefore, electronic configuration of copper is 3d10 4s1. That one electron is lost from the 4s orbital. Therefore, the electronic configuration of copper must be 3d10 4s0. In 3d10, how many unpaired electrons are there? 0. None of the above. Oh, I did not. That's why you did not choose. Is none of the above. I never knew that you are going to choose the closest answer. 1 is closest to the 0. That is why I have chosen 1. Is that clear to you? The number of unpaired electrons Cu plus is going to be 0.